Welcome back. Hey, it's Peter here, Tech Suvara, and today we are going to continue our journey with our clean software architecture for iOS apps. Last time it was kind of impromptu. I kind of jumped on it. I didn't even have Xcode ready. I have an Xcode project ready with this new architecture, and what we're going to do is we're going to continue on from what we did with the presentation and the use case layer. I'm going to walk through that as a quick summary of what we did last week with the actual project that I have. And I will actually have, we'll write up the services layer, right? So in this case, what we're going to do is we're going to expand on one of our use cases that are there. We're going to actually create a new one. We're going to create a new use case. We're going to connect it to some services. And basically, that will show us how we can create a really nice and easily testable system. Basically, we'll have a services layer that provides us with either mock data or real data, or transport layer data, depending on how you want that service to be implemented. You could have a different platform, you can have a different data set. It's really great for testing. There's also, we're going to have a look at how to split between live data and mock data. And we're also going to look at how use cases use services to perform actions. Now, use cases, because we're using a combination of combine to send data to our view and view model for in the presentation layer. Use cases run procedurally, right? So we send messages to the view state, to the view, not the view state. We send messages to the view via the state, right? So the state, the document object model is clearly defined. We'll go through that. And so it's very exciting to actually talk about this, because it's taken so many iterations to get a really nice, fluent, fast, and really elegant solution that works. And it's so much better than anything I've used. And I've used React. I've used RX React Native. I've used all of the content management systems like Drupal, WordPress. I've used Angular, and I've used like the old standard UI kit stuff on iOS. I've actually built my own menu systems from way back when I was doing video games, and I had to build video game menu systems. So I understand how that stuff works. And I'm really, really happy to say that this kind of entire architecture, it really fits well for applications on iOS. And you know what? I have to say, if you don't really need the web anymore, in the sense that if you want to solve a particular problem and you want a tool to solve it, apps are so much better than any website. And I would always, if there is a web app and if there's an app, I will always pick the app on my iPad or iPhone than I would on a website or web app on the browser, always. So no matter what it is, everything from, YouTube to, let's see, DaVinci Resolve to, well, it's not a web app actually, but to, let's say, Facebook, let's see, Instagram, all these kind of things, Twitter, or Twitter, whatever app, if you can think of, then I would always pick the mobile native application. Anyway, let's get into it. Let's talk about architecture and not about the preferred way of doing apps and web apps and which one's better, but let's talk about software architecture, especially on native iOS. Let's do it. Hey guys, okay, so here we are, we have our application. This application basically is a list that shows cards, and each card, when you tap it, shows you information about it. It has a state of whether it is expired or not, and it has a different color on the actual indicator. So it has basically our model for the card is card definable. So we basically have a title, a color, and a data string, right? So we have that's the protocol. This is a card item. It's an instance, and we can basically define a hash to basically list these things in order and create creatable. So basically, we're at this place now where we have our presentation layer, which we talked about, right? This is our presentation layer. We have our main view, which is the main view that we talked about last time. Inside the main view, we have the main view model, same thing. We have these published items. These published items basically feed information into the view, and the main view model has a source of dependencies, and these dependencies come from the domain. Now, one of the things that I didn't really go into was the domain. So what happens in the domain layer is, if we go there, we close the presentation layer now. In the domain layer, we have our global state. So this is like our document object model. It's the object model that's used for the state of the app. It's this thing that the whole state is managed this way. Basically, it is live. There's no persistence in it, in the sense that it isn't saved to file, it's just in memory. So this is what we would expect our memory state to be. So in this case, we have our app state, which has our user account. Substate, user account has the cards. We have the selected card, the number of the cards, and we have an original card, original cards. Right, so we can alter them. We also have the use case state definition. And basically what happens is we have this use case state that is pushed, that has these publishers that sends information whenever things change. Now the magic, I mentioned previously that I wasn't really keen on sharing with how this works, but I'm going to do that because it's something that I've personally built up over the years based on working with systems that are very similar, and I've evolved them myself. Now what happens is we have our state accessor, right? We have this queue. There are different ways of doing this, but this prevents race conditions. So we basically have a queue. We can only set things one at a time. When we get them, we can get an unsafe state, but we get a copy of it, right? So we essentially get a copy of what we want when we do the get. So when the state updates, it updates one item of that state. So that it informs this state subject, which is a subject that listens to the entire state, to update basically and send information. And that happens once, that gets into the publisher, and then it gets fed out through these different listeners. So if we look at the presentation, we can see that in the main view model, we listen to the publisher on the cards. So this picks up a listener to here. And what I talked about before was we don't necessarily, this is for the actual view model, right? But we can create the instance of our own view model with our own dependencies. And so if we wanted to have a list of items that are updating, we can have dependencies and have a combine object that updates this every so often, right? So that's how you would do it here, right? When you wanted to do basically an update. We also have an error subject. I mentioned the idea of errors. So the next thing we're going to look at, right? This is the services. We're going to create a service in our user account use case, right? So we have use cases that I mentioned before. Use cases are registered. They're either mock or live use cases and they have a container. So we register a class, and then whatever wants to use the use case will use it. In this case, we have in our presentation layer in the view model, main view, we have a user account use case. And all we do is we ask for the class, and it'll give us whatever's active at the time that we want to use for that instance of the actual application. Now, what are use cases used to perform their actions, right? Use cases are in the domain space, they're in the business logic space, and they're used for managing the actual definitions that are used by the business and the user, right? So that's why they're called use cases. So essentially what they do is we go, what's the user account use case? And say we want to have a service, right? So what happens here is we have our dependencies here, but we're going to scrap this, and we're going to create a slightly different way of doing services, and I'll show you how that will work. And essentially what happens is that the use case will have a dependency, not as mock or live like this, but we'll have also dependencies like a default, right? So we'll have a default set of dependencies, and we'll have a service here. So let's start with how we want it to look. We essentially want to go, service. So let's see, service provider. So we'll go services. We'll go services, and we'll have a static call for the services for the instance here, which will be login service, right? we'll just call it login service, and then we'll create a new, let's see, we'll go to 3 cards here, we'll create a new group, and we'll call it services. And what we do in services, we'll create, essentially, there'll be a new file, we'll call it a Swift file service provider, right? Service provider, which will give us all of the services. And then we'll create another new file, which will, our new group, which we'll call it the login service. And in the login service, we'll also create a new file. New file, which will be Swift. Basically, we want is to be the login service, and the login service will be a protocol, right? And the reason we have this is because we want it to be able to implement mock and test objects. So we put protocol login service, and we'll just call it like func login user name string, and then just password, whatever, right? String, and then we'll also have, well, generally it should be called with name, and there's different ways with which you can describe the functions. Then we go func login user with, we'll just go with Apple, right? So we'll have those two, and we'll create 2 definitions for it, right? So we want to basically we want to be able to test this without having to do all the work that, we want to test the UI. We want to be able to validate that we can style things. So we want to create an implementation of the mock, right? And that's really easy. You just create another file and you just go mock login service, right? Mock login service. And then we'll just go, class mock login service, which will extend login service. And here we want to use async await just to kind of simulate things, right? So we would take this and we'll just go task.sleep. Okay, so we have to make this async, right? And then we'd have to go back to the login service and make the definition async also, right? So async. Cool, we've got that implementation. And then we'll go wait. And because this is in nanoseconds, we go 1. Oh, shit, I think this is 1 second, right? Cool. Sleep is deprecated. Nanoseconds. Okay. Nanoseconds. Okay, we want to wait 1 million nanoseconds, and we go try. Basically, don't care what the error is in this case. It's just our mock, and we'll do the same thing here. Async, and that should give us our mock service, right? Now, so what do we do here with our service provider? Okay, so we have our class service provider, right? And we want an instance of service providers basically for the use case to be able to test and run based on whatever we wanted to actually have implemented at the time, right? So use case will have a set of dependencies. We can create an instance of the use case depending on what we have active. In this case, we have, say, login service, right? Login service, we have an instance of that. And then we would have, let's see, login service. And well, yep, do that. Login service equals login service. Pretty straightforward. We then also have, let's see, so extension service provider, right? So now we want to create definitions for our, we want to mock services, right? And our live services. So we have 2 service providers. We've got static let. We have our mock service provider, which will be a service provider. And basically what we do here, start init, and then we just go mock. So this will be static static instance. If we ever wanted to pull a mock service for use, we would just go mock service provider, right? And if we had, we want to put live, our live service provider, we would use live login service. So live is like the real world use case, the app use case, the app use service, right? So it would be the actual implementation. So to do that, in order to facilitate this, what we do is we go live login service, create it, and then we just go class live login service extension of mock for now, right? But this gives us the ability to create the system to provide services when we want mock data, and then just implement live when we want to, right? So we would implement the live implementation, and that would be working the way we wanted it to. So next, we actually implement the accessor for our app that decides for the use case what it will get when it asks for the static. So basically what that means is when I'm running the app, what is effectively the service that I want to use in the live service. So what will the use case by default pick up, right? So for testing, if we want to test that a particular service is working, we would use the instance of the service, and then we would test it. If we wanted mock to do certain things, we'd get mock. It's a great way to just plug in tests and then use the one that you want to use for what you want to use when you decide to run the application itself. So we go service provider, right? So here we actually have static, right? So let's say login service, right? And this will just be the actual the live instance, well, not the live instance, the instance we want to use for our use cases. So this basically is telling us default. We'll call it default login service, right? And this will return. So what we want to do in this case is just say we were going if hash available platform was it iOS, right? So if we're running on iOS for now, this is just an example. If hash available return we want to return our mock service provider dot login service. Otherwise we want to return. So if it's on iOS, but if it's on, say, Mac OS, right, we want to return live service provider login service. Now, this is just an example. There's different cases which you could have different providers depending on what you. So we've got a login. iOS would be like, we might have a Mac OS service provider. We might have an iOS service provider. You might have a test service provider. I think it's iOS 13. Right. Okay, yeah, that's right. We can't have let. So, okay, cool. So we have our default login service. So we go back to our live login service here. And just as live login service does what the mock login service does now. And we'll go into the use case, user account use case. There it is, user account use case. And we want service provider default login service, right? And now dependencies will have, say, let login service. So the use case doesn't care. The use case should never care with the implementation, right? So this is the great thing about it. You don't care what particular login service you're using. The end result should be the same. The service should do the same thing. It's decoupled, right? It's decoupled from the use case. The service have platform knowledge. The services have specific platform knowledge that we use, while the use cases don't. The use cases have business logic, domain logic, information about how they're going to work. And they don't want to know about the platform. They're platform independent. And that's what I mentioned in the previous video. The services layer is the one that's connected to the platform, and the login service here is either going to be a mock or a live. In this case, it could be anything. It could be Mac, like I said, it could be Mac OS login service, it could be iOS login service, it could be iPad OS login service. It could be whatever platform you're using. So we'll fix that up. So in this case, let's see, we want to, fix the accessor. Yep. Now, I want to take out this dependency conformance because this is something I was going to do, but we don't need it, right? Dependency conformance. We don't want the use case to care about whether it's mock or live. We want the use case to use whatever we have available for it through the default login service, right? But if we wanted the use case to use a different login service for test purposes, we would create our own static instance here and pass that to the initializer. So in this case, we just go to default, right? Okay. And I don't think we need this okay. So use case needs dependency environment. So I've made some things that aren't necessarily required. Get that out of there. Get out of there. As one of our friends on YouTube would like to say. All right, so we have that. Now let's build it. So we should have a login service. Dependencies has no member. Mock. Okay. So what's happening here? Register use case. We don't need that. Okay, we don't need that. Okay, we don't need this. Okay, so here, one of the decisions that's made here is we use mock straight away, right? We don't want to do that here. We just want to use use cases. We want to register use cases. Register use cases. Okay, this is the use case that we register when we start. We'll call that here, register use cases. Let's see, I don't care here about it. Use cases, register use cases. Okay, so this should just run as before. Yep, read stop. Cool, that's what it does, right? So our next step here would be, what do we do with the state, right? So we have we want to have an indicator that we're logging in. We don't really care how it's happening. So we go into our user account use case. We have I guess our initializer with the dependencies. So we just for the sake of argument, we have I guess when we initialize, right, we would then just go dependencies dot login service login with Apple, and this would need to be wrapped in a task, and we could just make it go login, right? So we have a use case that has a function called login. We can do that anywhere, right? So we could have let's have another button, right? And then we'll just go. We'll need to add an instance of our login service here, login service, and we would need to assign it login service equal dependencies login service and login, and this would be login service dot login with Apple, just as it login with Apple. Why not login with Apple? Just to make it easier. Okay, and we do that asynchronously. And, we could even go and say in our state, let's go, login state, we'd have like a logging in equals true. So we just go into our state, which is the user account state here, and we'd have a var logging in bool equals false by default, right? So now all of a sudden, we just go logging in, and then state logging in equals true, logging in equals false. Hey, wait, right? So the great thing about this is our state management to the view is done by messages, but our activity in the use cases, so the user actions that are performed, are done procedurally. And the great thing about that is we can notify asynchronously all messages to the UI. You can update the UI completely independently. So basically, you're not telling the UI what to do when you're using the use case. You're basically telling the state in the domain layer, right, what to do, what's happening, what's happening. And the presentation layer responds based on what is happening and neither of them care about the other. The UI and the presentation layer doesn't care about the business logic and what's happening. It's just showing a representation of the state. It doesn't care about what's happening and how it's happening. It's going, well, this is the state as I want it to be presented, right? And they're completely independent. You can test them independently. You can have a test use case that feeds into the you can have test data that feeds into the presentation layer, and you can have an independent use case that you just test the data for. All right, so the next step in our process is to go into the layer, the user account state. Let's see. Now we want to go into the main view, right? So we have the main view, and we jump in here, and we just have another button, right? Before this in the H stack, just same thing. This stuff here that we have, we didn't have a modifier, we just said login, and the model will just go login. Let's just log in, right? That's what we do. We log in, and we might have trouble with the size of some of these buttons, so let's just make them 80 because they might get squeezed. So the beauty here is, right, is that we don't care about the UI doesn't care about how and what this login does. It's just saying, oh, well, let's tell the view model login, and the view model goes, well, in the user account use case, login, right, with Apple, and also doesn't care how it does it. It just goes, well, I'll just do this, right? And what we want to do here is we want to add another listener for the state, right? Logged in, logging in, right? So there is some verbosity to this, and I think you can use macros to fix that, right? But the idea is, right, logging in, say publisher, is that you're much safer this way. You can compartmentalize and create areas of code and test areas of code. So if something breaks, it's very separated, and it might be a little bit more verbose, but it's definitely worth it in the long term. So we also want to pick this up. We have, say, published var, it's false. And then here we go var show cards. Oh, and then show cards if we're not logging in, right? That's it. And here we assign it. We go dependencies dot logging in dot assign to logging in. All right. So that's it. Let's see what happens next. So basically what should happen now is we build it, and when we press the login button, it won't show the cards for 1 second, right? That's theory. So the UI just goes, okay, well, while we're logging in, don't show the cards. We don't care how it happens. And if you had a live service, right, you would do that by actually, you'd have that by actually not, by actually logging in, performing the actual login function. So let's see, does it work? No, that didn't work. And why didn't work? Let's see. Login with Apple, login equals true, logging in, false. All right, let's see. Why didn't that work? Oh, no, that should work. Okay, here we go. Say logging in. Wait a second. Sorry, guys. I didn't actually put the condition on to show to not show the cards. So my bad on that one. I'll go back to the main view, and we'll just go pretty straightforward here. If model dot logging in show cards. Okay, now it's gonna work. All right. So that's why it didn't work. I didn't actually put the condition. You get too excited. Should have just. There we go. Got the breakpoint. It'll set it, and then we bang. Right. There you go. And what we can do here is to make it look nicer is, given that we have a VStack, we just go else spacer. Right. That's one way of doing it. Or we could just have it hidden. We'll see if this works. I think Spacer will push everything out, so it should work. Yeah. Cool. And what we can do here is we can go Spacer, Spacer, and then we just do text. Right, so now you just evolve, and now you get your service, you're doing everything, now you put in the UI. So now we have text, let's go logging in, and font, title. All right. You should be pretty familiar with this stuff if you have done SwiftUI. All right. So that's how easy it is to link things and keep them separated in a way that makes gives you the ability to build your UI, but also proof it up against functionality that you know you will need later. So we have this mock service. We'll implement the live stuff later. Let's just get the UI looking nice. You could implement an entire app based on mock data, have it ready to be able to represent the entirety of what the functionality that you want without implementing one piece of real service layer. Right, so that's the theory. You can iterate really quickly, build all this UI, get users to use it. Excellent for MVPs, excellent for building and prototyping certain things. And then when you want to implement the real thing with Firebase or with Apple or with whatever, you can, and it works. I've done this numerous times, and I've actually built an entire app for a client where we had the UI layer ready, and then we could then tweak the UI based on what we wanted, and then work on the actual physical transport layer for the web, right? Second. So they got the best of both worlds. They could make tweaks in the UI without impacting services and connections and all those kind of things. Logging in. There you go, guys. And that's it. So if it wasn't for that little mistake of not putting in, it would have been a perfect run. But yeah, guys, I hope you enjoyed this video. And next week, we're going to jump back into Mojo programming. So thanks very much, and I'll catch you later. Bye.